So that we can take some huge powers of complex numbers without much trouble if you use De Moivre's formula. But here's a slightly more interesting application. Suppose you want to find x to the 6th power equals to negative negative 8. And the question is, find all such x. Find all such x. Now we know that x cannot be a real number because you're taking an even power of something. If x was real, if you take the even powers, it has to be positive, right? So you immediately know that there's no real solution to this thing. So we're only looking for imaginary numbers, so or complex numbers, complex solutions of this. Okay. First thing to do is convert the right side into a polar form. So if you draw negative 8 here, this is what we had. Okay, what's the length of this number? What's the magnitude of negative 8? 8. So as I said, the magnitude is same as taking absolute value if it's a real number. So it's just 8. What's the angle? 180 degrees. Okay, and on the left side, you just say x is equal to some number, which is r angle theta. Then what is x to the 6th power? R to the 6th power, angle 6 theta. And you're trying to set these two equal to each other, right? So we have r to the 6th power 6 theta equals to 8 times 8 with angle 180 degrees. This is theta here. It's a variable. Okay, so therefore, for these to be equal, we know that they will be equal if r to the 6 is 8 and 6 theta is 180. All good? Sounds about right. Yeah? Okay. What is this? Can you solve this? Well, 8 is 2 to the 3rd power, right? So if you take a 1/3 power both sides, then you end up with r squared equals to 2. So you get r equals to square root of 2. Did you follow?
Yeah, no, is that a square or 1/3? Well, that's
1/3. Sorry. Maybe it's not written clearly. R to the 6th. I have r to the 6th equals to 2 to the 3rd, because 2 to the 3rd is 8.
Yeah.
And I'm taking 1/3 power both sides. Because if you take 1/3 power, these two multiply, they cancel away, leaving you with 2 here. And 6 times 1/3 is 2, so I have r squared equals to 2. Therefore, I have r equals to square root of 2. Here, I'm assuming r as the magnitude, so you don't take the negative value. R should always be positive. Okay, so we have the first result here. R should be square root of 2. What about this one, 6 theta? That means theta is 30 degrees. Putting these two together, we know that x equal to square root 2, 30 degrees, is a solution. Now in these questions, I might ask you to write your solution in polar form, or it could be in rectangular form. I could also ask you to write it in Euler form. So let me rewrite this in both rectangular form and Euler form. Now first the Euler form. Although we are allowed to use degrees in the polar form, when you write things in Euler form, you have to use radians. I mean, I guess it's not totally wrong to use degrees, but see, degrees is not good for calculus. There's some reasons for that. So whenever you're using the Euler form, you want to convert everything into radians. See, Euler form came from calculus, and therefore, for some reasons that I don't want to explain too much, you want to write it in radians. Okay? So 30 degrees is what in radians? Well, 30 degrees is 180 degrees divided by what? 6. What is 180 degrees in terms of radius? Pi, right? So it's pi over 6. Therefore, in Euler form, you should write square root of 2 e to the I pi over 6. That's how you write down this answer if the question was write your answer in Euler form. Now for rectangular form, you write square root of 2 angle 30 degrees equals square root of 2 cosine 30 degrees I sine 30 degrees, which is square root of 3 over 2 plus I times 1 over 2, and that gives you square root of 6 over 2 plus I times square root of 2 over 2. So that is one solution of that. However, this is a sixth order polynomial, and if you count all the complex and real solutions of such a sixth order polynomial, how many solutions are you supposed to have? 6, counting multiplicities. Okay. Now this one doesn't have multiplicities. I can't explain. But anyways, what I'm trying to say is that there are more solutions than just this one. Okay. So we have to go back and see where we missed anything. Okay. So let's go back to our logic. R to 6 should be 8. There's no other choice. It has to be. The magnitude should be equal in order for two numbers to be exactly on the same spot, right? What about the angles? Can you say something otherwise than say that they have to be equal?
It depends on the quadrant.
No. They should be in the same quadrant. That's not a problem. Yes?
Would it go in the opposite direction?
Not opposite. I don't want to say opposite. I mean, can you say something else?
Clockwise?
No, that's not what I'm trying to say. I mean, if this number and that number, if they have the same length and they have the same angle, but one's going this way and one's going that way, these two are different numbers. Okay, I'm not. They have to be at the same place, or else they're different numbers. What else can happen? Yes.
Add 360.
Add 360. Yeah, exactly. Okay. So what can happen is maybe they're not the same value, but they may be talking about the same angle because they are coterminal angles. Okay. So it could be that 6 theta is 180 plus 360. It could be that 6 theta is 180 plus twice of 360. Could be going around twice. It could be 3 times, 4 times, and all those will be valid answers. Okay. So here's what we have to do. This is not the end of the solution. You really have to say 6 theta is equal to 180. If you add 360 to 180, what do you get? You get, you know what, I think at this point it's better to use radius. It's easier to say pi than 180, right? It's easier to write. So sometimes having radius is actually easier to calculate. Okay? So first, you could say 6 theta is equal to pi. 180 degrees is pi. Right? Or you can add a 360. 360 in radius is 2 pi. So if I add 2 pi to this, you get 3 pi. If you add 2 pi to this, you get 5 pi. If you add 2 pi to this, you get 7 pi. 9 pi. When do we stop? When you have 6 solutions. Oh, that's very good. Yeah, you guys are smart. Okay. You have 11 pi. See, this is a 6th order polynomial on the left side, and that equation does not have any multiplicity at all. And if you know that, then you would expect 6 distinct answers. So you would do this for 6 times. When you have 6 of them, then you expect the next one will probably come back to one of these, because you can't have more than 6, definitely. So divide by 6, that's easy. 3 over 6 is 1/2. 5 pi over 6. 7 pi over 6. 9 divided by 6 is 3 over 2. And 11 pi over 6. Therefore, the answer is, if you write in terms of polar form, we know that x must be square root of 2 angle pi over 6, or square root of 2 angle pi over 2, square root of 2 angle 5 pi over 6, square root of 2 angle 7 pi over 6, square root of 2 angle 3 pi over 2, and finally, and square root of 2 angle 11 pi over 6. And of course, I could be asking you to write your answer in Euler form or rectangular form. In that case, you have even more work to convert every one of these into those. Changing it to Euler form, that's not a big deal, but changing it to rectangular form, that's going to take some time. One final remark. See, all the magnitudes are the same, right? Therefore, if you plotted all these complex numbers on the complex plane, what shape would they make? A bunch of places with same distance from the origin, well, what shape would they make?
Circle.
Yeah, they will be part of a circle, right? So let's say this is square root of 2, then if you imagine this circle of square root of 2, all these solutions will be on this circle. The first one being 30 degrees, we know that it's 30 degrees, right? And the next one is at pi over 2. The next one is here, that's 5 pi over 6. The next one is here, which is 7 pi over 6, 3 pi over 2, and 11 pi over 2. So you have 1, 2, 3, 4, 5, 6 numbers satisfying that equation. And this is always true. If you have the form of an equation that looks like x to the n equal to a number, or it could be a plus bi, whatever. If you have such an equation, then the solution will always be on some circle whose magnitude is determined by the nth root of the magnitude of this one. And the numbers, their solutions, will be evenly spaced on this circle. So this length, that length, that length, that length, that length, that length, they should all be equal. So if you know that, then that's also helpful to check whether you got an answer that makes sense or not.